In this lesson, we'll talk about some of the ways that we can extract our high-resolution detail in the form of image maps. So here we have our high-resolution model, and we'd like to get this out into maybe another application, maybe something like Maya or 3ds Max. But the model right now sits at about 1.8 million polygons or so. And when you start getting your models up here into the millions of polygons, they're going to be difficult to work with at that resolution. So what we want to do is extract all of the high resolution detail that we have here in the form of a map that we can then reapply to our lower resolution geometry that's a little bit more, we're able to deal with that a little bit more easily. All right, so what we can do is we'll go up to Maps, Extract Texture Maps, and let's create a new operation. Now we have a number of maps that we're able to generate here in Mudbox. We're able to generate an ambient occlusion map, which we can add onto our texture. It creates the sort of darkness in any of these lower raised occluded areas. We can do that. We can also create a vector displacement, which we kind of looked at when we were creating the spine, but we'll go into maybe a little bit more depth on that. And then we also have displacement and normal maps. Displacement maps are actually going to use a height map to actually move the geometry. So you're able to get the silhouette changed as the geometry is smooth at render time, and we use the displacement map to displace that. A normal map is not going to change that edge, but it is going to give you a good look here at some of the bumps and some of the raised areas inside here, but it won't change the edges. We'll look at both of those. So let's go into displacement map, and here it gives us a little visual indication of what's going to occur here. We've got the target model plus the source model. It's going to equal our displacement map. So our target model is going to be our low resolution mesh. So in this case we're using a single model and several subdivisions of that, but in many cases you can use different models. So if you had a high resolution model that had a bunch of different pieces on it, and you've added a bunch of different pieces, and then you have a low resolution mesh that is a single piece, you can bake those together. So in this case though, it's going to be a single mesh. So let's go ahead and we can add all, we can add selected, we can go back in and remove targets if we want to. We can change the subdivision level for the target. So you don't have to do it on level 0. If you wanted to use maybe the second level, which would be level 1 here, you can maybe do that. We'll go ahead and leave that on level 0. We also have the ability, depending on how many targets we have, how they're laid out, whether we want to create a map for each one of those targets or a single map that encompasses all of them if maybe they're on the same UV map. Okay, and we have the smooth target model, which uses a smooth version of the model for the extraction. Default is on, but if you're going to be using it for something like games where you don't necessarily need that, you can go ahead and turn it off. For the source model, we'll go ahead and again add this in, but this time we've got, you can see level 5 selected, which is our highest level. All right, so this may be a different model. In this case, it's the same model with a different subdivision level. All right, you also have the ability to smooth the source model, but we'll go ahead and leave that off. Okay, let's go ahead and move down here to the locate method. Now we have a raycasting method, and now we have also a subdivision method. And you'll see that with raycasting we get a few of these options, and then with subdivision a lot of those get grayed out. So the raycasting is going to create samples along the surface and cast rays out to find the high resolution mesh, and then create the map in that way. Okay, so right now the samples are set to furthest outside. We can change how those samples, if the samples shoot out and they come in contact with multiple parts of the high resolution mesh, this will tell it which ones to actually use. We also have the search distance, so if we hit best guess, that will give us a good indication, a good starting point of that search distance between the low resolution and the high resolution. So we're looking at the distance between those meshes. We also have the ability to, if the ray intersects with something that's facing backwards, whether we want to actually test that or ignore it. Okay. Now beyond ray casting, now this is good for if you've got kind of arbitrary meshes, if you've got a bunch of different things in here that you're trying to bake. We can also use subdivision, which you can see grays out all of these, and this simply looks at the points on the low res and on the high res, and then records the difference. So this will be used for objects that have the same topology basically. So it's a little bit faster. You can use this on objects like this where we're using different subdivision levels of the same object. All right, so those are just two different methods. The vector displacement only uses the subdivision locate method. We can choose an image size. We can anti-alias that. We can also, if we're using an 8 and 16-bit, we can normalize that search distance to between 0 and 1. We can also choose a file name. So let's go ahead and open that up, and we'll just choose displacement. Here we can choose a different type of file, and you can see right now it's set to 8 bits per channel. And so we have a few different options in here. We have some 8-bit images that we can use. We have 16-bit TIFF that we can use, and then we have a few 32-bit options, notably the TIFF and the OpenEXR format that we can use. And so just think of this as 8-bit is going to be like 8-bit per channel. So you're going to have, in this case, 256 height values that you can have. So if you're trying to get a lot of high-res detail, you may get some banding on that, but it may be suitable if you're looking for something that's a little bit more low resolution. The 16-bit, you'll have a lot more height values available, but you'll still sometimes get some banding. So 32-bit images are recommended for getting the most out of your detail and getting those in. And you can use TIFFs or the OpenEXR format to do that as well. So if we want to go ahead and just, let's actually look at just a regular displacement first, and we'll call this 8. Okay. And we can go ahead and save that out. We'll turn the preview off. We'll look at that in just a second. So what we want to do now is, once we've got all of our options set, let's go ahead and do the extraction. It's going to bring up the map extraction results, and you can do multiple maps at once too. So it says it's finished successfully, so let's go ahead and take a look at that in our image browser. And so this is the map that we just created. So you can see that we've got the height values recorded as gray here in our displacement. All right, so this would then be applied in something like Maya to actually move the geometry up and down. All right, let's go back in here, and we can go into our same extraction. If we want to change this up a little bit, go ahead and leave those settings the same. Maybe we want to change this to a different type of format, so let's go choose the EXR. And so we'll go ahead and save that out. And let's do an extraction on that. Map extraction finished. So now we'll go ahead and take a look at this. And here's our EXR, and it looks a little bit different because it's got that additional information that we're not able to view on our monitor. So if we go ahead and change the stop, you can see we can view some of this information just going up and down with our plus and minus. So we've got information recorded in the grayscale values, and then we have additional information above white, basically, and below black, if you want to think of it that way, that we can't see on our monitor. Okay, and if we take a look at the spine vector displacement we looked at before, it's got kind of the same kind of thing. If we look at those settings in here, let's for instance go into vector. Okay, we won't do this because we already extracted a vector displacement, but you can see that we don't have any of those options for that locate method because it only uses the subdivision. So all we have is the image size that we're able to use there, and we know it's going to be 32-bit, so we don't have a choice on that either. So if you go in here, you can see we only have 2 options. So it kind of eliminates the thinking about what format do I need to save it as. If you're doing a vector displacement, it's going to be one of those 2 formats there. Okay. All right. Let's look at creating a normal map. Now, a normal map is going to be useful for us even here in Mudbox. So let's go ahead and I'm going to just move down a few subdivision levels. Let's say that we're having trouble moving around, or we're getting too much geometry in our scene, or we want to just be able to move a little bit quicker, but we still want to see some of that high resolution detail in here. So maybe we want to come down to level 3 or level 2 possibly. So I'll go ahead and just page down to get down to one of these levels here. And so maybe we're at something like this. So let's go in and extract. We'll create a new operation, and this time we'll do a normal map. All right, so we'll go ahead and add our target model. This time, though, we're working on level 3, so let's go ahead and use level 3. All right. So we'll go ahead and, again, add our source model, and we'll use level 5 for this. Okay, we can use subdivision, simplify things a little bit. We'll just leave that the same. Now under here, under compatibility, since we're using a tangent coordinate space, Maya and 3ds Max treat those a little bit different, so that's why that is there if you're using a tangent space. And this will be used mainly for objects that are going to be deformed. You also have the ability to use object and world space if you've got something suggested that if it's going to be possibly moving but not deforming, you could use object space and world space. I know some people use these differently, so just keep that in mind. If it's going to be animated and deformed, we're going to stick with tangent space here. All right. We also have the option down here to preview this as a paint layer. We're going to leave this on at this moment, so I'm going to go ahead and open this up, and let's just save this out, and I'll just save it as a bitmap here, and let's go ahead and save this normal map. Say OK, and so then we'll go ahead and make sure all of our settings are good, and then we'll go ahead and extract that. So that's going to save out our normal map, and it's going to be that sort of blue looking image that we saw. And we go ahead and take a look at this as we through here. So it's going to actually automatically add that as a bump, as a normal rather. So you can see in here, if we go ahead and turn that off, that's what it's going to look like. And then we'll turn it back on, and you can see all of those bumps come out. So it gives us a little bit more information here about our geometry. So if we're going in and painting some textures, but we don't want to really work with the high resolution model, this normal map as a layer can be useful. Okay, so we can bring that in, and then we have at least an indication of where those bumps will be without having that geometry in there. Okay, so you can kind of see how some of that detail comes in with the normal map. If we go into our image browser, we can take a look at it, and you can see that it has a lot of just that high resolution detail. Let's go ahead and try calculating this at a lower level. So let's go ahead and take this down to level 2, let's say. Let's actually go down to level 1 and try it. And let's recalculate that normal map. So let's actually go back into our normal map. Okay, and this time I'm going to choose level 1. Okay, and let's go ahead and I'm just going to change the name of this and just put a 1 after it. Let's go ahead and extract that. All right, we'll go ahead and close that out. Okay, so now we get that normal map on this lower level. And if we take a look at the new normal map, you can see there's a lot more detail, whereas this one, we're just getting that skin detail because we're on a higher level. Once we get down here, we're actually getting the detail for some of the musculature and things like that that we can apply, the spine. So you can see the difference it makes by depending on what subdivision level or what level you calculate that from. All right. So those are a few ways that we can extract maps. Keep in mind you can also extract ambient occlusion maps in the same way, and you can also extract a vector displacement, which we looked at when we created the spline. And just remember, the vector displacement, you have to have topology that is the same. So it really works on objects that are basically different subdivision levels of the same object. So it only uses that subdivision location method. And then if you want to create a regular displacement or normal maps, you can use subdivision or ray casting depending on your particular application. Okay, so we talked a little bit about map extraction. I think the next thing that we want to look at are the new pose tools. So we'll go ahead and check those out in the next lesson.